Hey guys, today we're going to continue our discussion on geology. So far, we've been looking at what we would call constructive forces, right? So, the internal heat engine, convection currents, which drive lithospheric plate motion, creating divergent boundaries, convergent boundaries, earthquakes, volcanic activity. Those are all forces of uplift that raise the elevation at Earth's surface. So today we're going to look at the forces that counter those. We call them leveling forces, and they tear everything back down again. We refer to these as surface processes. And really, they're governed by the water cycle, which is driven by the sun, and gravity. So, water is a natural lubricant, and it helps to break rocks down at Earth's surface. It's also a really important agent of erosion. It transports material, and then it relays that material back down. And that's what surface processes really is. It's the breakdown of rocks, it's the movement of those sediments, and then redepositing that material. It's actually pretty important, right? Because rocks contain a lot of inorganic nutrients. And that material would be bound up in the lithosphere, in the rocks, if it were not for the processes of weathering, erosion, and deposition, the surface processes that help to redistribute those nutrients and ultimately make them available for producers. All right, so we're going to look at this as sort of a three-pronged system. We're going to start with weathering, we'll move on to erosion, and then end with deposition. Weathering is the first step. It's breaking rocks down. Rocks break down at Earth's surface both physically and chemically. Physical weathering means there is literally no change in the chemical composition. It'd be like having a rock on a desk and taking a hammer to it and smashing it into thousands of little pieces. Chemical weathering, on the other hand, there are chemical reactions taking place. There will be a change in the chemical composition of the rock. Both of these types of weathering take place when these rocks are exposed to the atmosphere. That's when weathering begins. That's when rocks begin to break down. So let's look at a couple examples. The first example is what we would call frost action. Right? We know this pretty well. So if we take a can of Coke, and we've probably done this, and put it in the freezer because you want it to get cold quickly. The problem is sometimes you forget about that can of Coke. I've done this many times. And you come back the next day and it's a mess, right? Because, of course, the Coke, the liquid, the water in the Coke freezes. And when liquids freeze, their volume increases. The problem with that is, of course, the Coke is confined to a can, so oftentimes it can expand the can, causing it to split and making a mess. So there is a form of physical weathering that we call frost action, and it's the same premise, right? When water seeps into a crack in a rock, when it's warm, and then it freezes, that water will expand due to the freezing process. That expansion is going to break apart that rock physically. Exfoliation is another type of physical weathering. It's literally the rock or sort of Earth's surface peeling away. It's a lot like a bloomin' onion. I love bloomin' onions. And the way this works is that oftentimes rocks form deep within Earth's crust. We talked about intrusive igneous rocks, for example. Well, you can imagine when those rocks cool, harden, and solidify, they're still under an enormous amount of pressure. And sometimes joints or breaks in the rock develop under that pressure. And then ultimately, when uplift occurs, maybe some sort of tectonic activity, that rock is now exposed. There's a huge amount of pressure unloading. So it's like this sigh of relief, and all of a sudden the rock layers just start to peel away. Of course, here's Half Dome, a rock climber's mecca, and this is what we would call an exfoliated dome. In other words, this intrusive rock mass formed deep within Earth's crust. Tectonic activity brought it to the surface, and those rock layers just sort of peeled off, creating this amazing geologic formation. Roots and animals can also burrow and break down rocks physically as well. Plants, typically any trees, for example, are just looking for a platform for growth, and sometimes they'll insert their roots into the cracks of rocks. Well, that tree's going to grow over time, and as it does so, it's going to break up that rock. All right, we also have chemical forms of weathering, and again, here is a change in the chemical composition of a rock. Certain metallic elements, like iron, for example, are relatively stable when they're inside Earth's crust, when they're buried. However, when these rocks are exposed to the atmosphere, those metallic elements undergo oxidation. In other words, they rust, just like our car. As oxygen is applied to these metallic elements, it chemically rusts or breaks down through the process of oxidation. Another really important type of chemical weathering that we're going to refer to quite a bit this year is a process of carbonation. We know carbonation's in our soda. So what exactly is it? Well, rainwater is naturally acidic. Before humans even goof around with it or cause acid rain, the precipitation has a pH value of about 5.6 on the pH scale. So it is acidic. Why is rainwater typically acidic? Because carbon dioxide in the atmosphere, a natural constituent, reacts with water and water vapor. That forms a weak acid known as carbonic acid. Well, here's what happens. When these weak acids fall to Earth's surface, there's certain minerals like calcite, which is typically found in limestone rock, that react to those weak acids. So calcite is found in limestone, and when it comes into contact with carbonic acid, it dissolves. It actually bubbles, and you guys probably remember doing that in earth science, putting a hydrochloric acid on calcite, seeing it bubble, releasing carbon dioxide. That's a chemical form of weathering. It's responsible for producing these amazing caverns with their roxicles, right? Stalactites and stalagmites. As the calcite and the limestone gets hollowed out through dissolution, it's dissolving. And those droplets of calcite-laden water that drop from the ceiling eventually harden like an icicle would, forming these really interesting structures that eventually hollow out these caverns. We are going to come back to this process quite a bit because this limestone, the calcium carbonate, dissolves, and that's going to have a huge impact on various environmental issues. We're going to be talking about different bedrocks and how they affect acid rain. Bedrocks that are comprised of limestone tend to help to neutralize the acids that fall from the sky. And so lakes that are underlined by limestone or rivers suffer less from acid rain because they're buffers. They help to neutralize those acids. We're going to come back to this topic as well when we talk about ocean acidification and the decline of coral reefs. After weathering, we have erosion. So weathering is breaking rocks down, and then they move. Erosion specifically is talking about the transport of sediments across Earth's surface. And it's primarily driven by gravity, right? Well, gravity alone can operate, and that can be pretty spectacular. Mass movements like landslides and mudslides, avalanches, these are all examples of gravitational erosion, material falling from high elevation to low elevation. But gravity is also responsible for the other agents of erosion. Let's face it, a river doesn't flow uphill, it flows downhill. And so we have other ways in which sediment can move across the planet. Wind, for example, dominates in very dry or arid locations. Without a lot of vegetation in those dry locations, there's nothing to help stabilize the soils. Ice, or what we call glaciers, can move a huge amount of material and very large rocks and debris. boulders the size of cars and houses in some cases. And they produce spectacular landscapes in their wake when they retreat. All of these agents of erosion produce some amazing, stunning, visually, the landscapes that we see at planet Earth's surface. Star water, because it is water, of course, that moves the most sediments on planet Earth. Rivers, running water. We only have to think of the Mississippi, sometimes called the Big Muddy. And the reason it's called the Big Muddy is because the Mississippi sits in a vast watershed with lots of farmland where there's an enormous amount of runoff coming from the land where it's delivering sediments into the river. Well, that river then continues to transport that material downstream where it all ends up in the Gulf of Mexico. So rivers are powerful agents of erosion. They produce spectacular landscapes like the Grand Canyon, and they move a lot of material. A lot of our focus will be on how humans are enhancing this erosion, right? So right now we're talking about natural geologic erosion. In the near future, we'll be talking about how humans exacerbate the problem, right? Human activities like mining, deforestation, and farming all have a tendency to promote erosion and therefore the loss of critical nutrients in certain areas of the world. After all of these things move, they eventually get deposited and laid back down, but oftentimes they're no longer in the location that they originally formed. And so we'll look at the consequences of that. That's it for today, guys. Have a good one.